So when we get to 28, we kind of add another little complexity to it, the finite population correction factor. So in this case, we're going back and we're using our t value here, okay, and same formula that we had before, right? That my mean plus or minus the t times my s, or standard deviation of the sample, basically divided by the square root of my n, or my sample size, okay. But the finite population correction factor is basically saying that in a lot of cases we assume that the population is extremely large or almost infinite. And if we're doing surveys of folks for voting and whatnot for elections, that's a very large population. I mean, basically the whole voting age population of the United States. Okay, and so we don't do a correction factor, but we do a correction factor when we know that the population's smaller. Like all the students on campus at Northern, right? I mean, that's a finite number. Okay, and we know that, and kind of what we're saying then is that we do this correction factor because if the number's bigger, if our sample size is bigger, we're going to get closer and closer to what that finite number is of the population. Okay, when the number's smaller, we're a little further away, and so we apply that correction factor. And all it is taking this formula then, and I've kind of got these backwards, but times this formula here, okay, the square root of my population size minus my sample size divided by my population size minus 1, okay, times my t-value and whatnot. So let's read the problem and get our data. Again, that's probably the most important part. So for number 27, anyhow, I've got 36 teams are randomly selected from a population of 300 items. So my population's 300. Okay, so that's my big N, I'll call that. And 36 is my smaller sample size, right? My sample mean then is 35, right? And the sample standard deviation given to me is 5. My confidence level is 95. Okay, that's what I want to get to. Okay, so I've got to calculate then what my t is in order to do my equation here. Okay, and to do that, mine isn't as full as your guys's, because remember how I calculate my t or look up my t is, again, I've got my degrees of freedom, which is my sample size minus 1, okay, or 36 minus 1, so my degrees of freedom would be 35, and if you look at my chart, it doesn't have a 35. Okay, I could interpolate. Okay, so this is 2.04 and this is 2.02. I'm going to be around 2.3, but if you look in yours in the B5 in the back, chart B5 in the back, it does have a degrees of freedom of 35, and in fact 2.03, it's actually 2.028. Okay, I don't know if I didn't round it, so, or I didn't extend it out, but 2.028 we could use as well. Okay, why I have the P, I don't know, my proportion. Yeah. Anyhow, so I'm going to do each of these formulas kind of separate. So my first is this one, right? And I've probably done, what I've done here is done inside before I take the square root. Okay, so I've got my simply equal to, right, parentheses, my big N minus my little n. Those are technical terms, right? Divided by my parentheses, big N minus 1. In parentheses. Okay, 88.294, and then I have to take the square root of that. So simply I'll use the square root function, and you can do whichever. Boom. Okay, there we have it. Okay, so then I'm going to end up multiplying that times this formula, right? And so here I've got my, just my sample standard deviation divided by the square root of n. I kind of put all of these together. I did multiply it times t, so I have the whole equation here. It's a little long, drawn out equation, but we'll see if we can do her here and get her right. Remember that it's 1.69. It's the same. That's what I'm searching for there. So equal to, okay, my t value times my s, my 5, right? I'm gonna do my parentheses times that divided by the square root of n. So I'm going to go n, my little n, to the, I probably got too many parentheses in here. Well, too many sometimes is better than not enough. Wow, that's a lot of parentheses I got in there. We'll see if that gives me the right answer, and in fact it does. Okay. Yet I would probably, even if you did it like this, like I just did here, where it's a little bit long and complicated, break it down by pencil and paper. Do each one of these, get your square root of n maybe first, right? The square root of 36, which is whatever the heck that is. Oh, 6. It's a tough one, huh? So 6, so I got s, 5 divided by 6, really, times t. And see, if you break it down, it sure wouldn't be that difficult, right? Okay. And then I take that times my correction factor. So basically 94% of that is what I'm going to be doing there, is equal to this times this. Okay, and then I've got to do the plus or minus my sample mean. Okay, so quite simply is equal to, again, my sample mean, 35, minus my number that I came up with. There you go, and then do plus 2. And so my range, right, would be between 33.4 and 36.6, roughly. So, and that's it for 28.